Force on a charged particle. In this video, we will discuss Lorentz force. What is Lorentz force? Lorentz force is the total force acting on a charge q that is moving with a velocity v in presence of both the electric field E and magnetic field B. That is, when a charge having magnitude q moves through a region where there is both electric field and magnetic field, then the charged particle will experience a force. That force is called Lorentz force. We have seen in electrostatics that when a charged particle is placed in an electric field, it will certainly experience a force, that is electric force. Same way, when a charged particle, a moving charge in a magnetic field also will experience a force. It's called magnetic force. So if it moves through a region where both electric field and magnetic fields are present, then it will experience both these forces, that is electric force as well as magnetic force. So Lorentz force is the vector sum of electric force and magnetic force. Now the electric force is given by Q into E vector that we have already discussed. But the magnetic force has got the form Q into V cross B, which is actually defined through the vector product Q into V cross B. Therefore, Lorentz force F, which is the sum of electric and magnetic force, becomes Q into E plus V cross B. That is adding QE and Q into V cross B, in that Q is common, so that is taken outside. So we have F is equal to Q into E plus V cross B. So this is the mathematical definition or mathematical formula to calculate the total force acting on a charged particle when it moves through a region having both electric and magnetic field, or otherwise the mathematical formula of Lorentz force. In the above equation, F is equal to QE is called electric Lorentz force, and F is equal to Q into V cross B is called magnetic Lorentz force. So Lorentz force is the vector sum of electric Lorentz force and magnetic Lorentz force. Now we will discuss magnetic Lorentz force in detail. We have magnetic Lorentz force is given by Q into V cross B. From the basic definition of cross product, the magnitude of magnetic Lorentz force will be Q into V into B into sin theta, where sin theta is the sign of the smallest angle enclosed between the direction of velocity vector and magnetic field vector. So from the magnitude part of magnetic Lorentz force, it is clear that magnitude of or the magnetic force is directly proportional to the magnetic field B. Magnetic force is directly proportional to the velocity. Magnetic force is directly proportional to the sign of the angle between velocity vector and magnetic field vector. Magnetic force is directly proportional to the magnitude of the charge Q. That is, if magnetic field increases, provided the other factors remains the same, that is velocity and magnitude of charge, then the force will increase. Similarly, if velocity increases, again force will increases, provided the other factors remains the same. Now, from the basic definition of cross product, the direction of this magnetic field, magnetic force will be in a direction perpendicular to the plane containing velocity vector and magnetic field vector. So the direction of magnetic force or magnetic Lorentz force is in a direction perpendicular to the plane containing the given two vectors, that is velocity vector and magnetic field vector. We can also find its direction using right hand corkscrew rule or right hand thumb rule. Now the direction of magnetic force on a negative charge is opposite to the direction of magnetic force on a positive charge, provided other factors are identical. That is, for a given velocity and for a given magnetic field, the force experienced by a positive charge and that by a negative charge differs only in direction. The directions will be opposite to each other. This is because the magnetic force experienced by a positive charge is Q into V cross B, whereas that experienced by a negative charge will be minus Q into V cross B. There the minus sign shows that the direction of force experienced by a negative charge is opposite to that experienced by a positive charge. Now this is how we find the direction of magnetic force experienced by a positive charge. When a positive charge enters a magnetic field B with certain velocity V as shown in the figure, then the direction of fingers, that is except thumb, is in the direction of rotation of the first vector, that is velocity vector, towards the other vector, the second vector, that is magnetic field vector, through the smallest angle enclosed between velocity vector and magnetic field vector. So if this is the direction of rotation of the first vector towards the second vector, then the thumb will give you the direction of magnetic force. Whereas in the case of a negative charge in the same field and with the same velocity, having the same magnitude, but only the sign is different, then the magnetic force will be downward, which is opposite to that experienced by a positive charge. So this is how we find out the direction of magnetic field for a given the direction of force, magnetic force for a given magnetic field and velocity. Now we'll find out the unit of magnetic field B. We have magnetic Lorentz force. The magnitude of magnetic Lorentz force equals QVB sin theta. On rearranging this equation, we have B is equal to F by Q into V. Actually, it is F divided by QV sin theta. In the above equation, we didn't consider sin theta because sin theta is a ratio. It doesn't have any unit. So that is why we did not consider sin theta in the above equation. So we have B is equal to get the unit of B, we require only this equation, B is equal to F divided by QV. So unit of B will be F. F, the unit of force is Newton, unit of charge is Coulomb, unit of velocity is meter per second. So we have Newton divided by Coulomb into meter per second, and on rearranging we get it is Newton into second divided by Coulomb into meter. This is termed as Tesla. So the SI unit of magnetic field B is Tesla. In abbreviated form, we represent Tesla by capital T. But Tesla is a very large unit. A smaller unit called Gauss is also often used. So Tesla and Gauss are the two units which we often use as the unit of magnetic field. The relation between Tesla and Gauss is 1 Gauss is equal to 10 raised to minus 4 Tesla. That is 1 G, G stands for Gauss, so 1 G is equal to 10 raised to minus 4 Tesla.